Thanks for joining us again on this video series. Internet filters, by their very nature, interconnect with other hardware and software. The core principles on which this software is built allows for a wide variety of deployments to occur, since the fundamental product building blocks are around the following key elements that you'll appreciate. First, this is a DNS resolver. It's optimized for fast caching as well as deterministic answers, which means one device may receive different answers than another one due to the policy assignment. The resolver also uses multi-streaming of public resolvers so it can get the fastest possible answers for you. Second, the stack is a micro web server designed to offer customizable yet friendly block pages to the internal network where it is deployed. Third, it is made up of a set of static as well as extremely dynamic set of firewall rules, depending on which features are in use. Fourth, the entire experience is managed via cloud-based controller, where all the management is deployed. Fifth, a browser assistant is available for Google Chrome by way of an extension. This tool allows for blocking TLS and SSL sites in order to offer the end user a much better experience. If you've used DNS-based blocking of any kind in the past, this may be a welcome change for you. And finally, a set of tools are available for the end user and administrative use alike. The one URL that should be distributed to all end users is mytools.management. It is a starting point for end users and sysadmins alike. The URL will always work on any internal network that has this software stack deployed. The second URL that system administrators only will use is mybox.management. This one offers a real SSL certificate for the purposes of device administration. The third URL is mydns.management, which may optionally be used for creating and maintaining a dynamic DNS hostname with your public exit point always staying up to date. In summary, the software stack provides site-specific services at mytools.management, mybox.management, and mydns.management. Next, I want to cover off the importance of a pre-installation survey that should take place prior to any planned deployment. This is often best done with a network diagram along with other important data to collect. You always want to collect, at the very minimum, the following pieces. Document your internal domains, such as mycompany.local. You see, internal domains require special treatment, and more information is available on the installation documentation. Next, you want to document your public DNS host entries that resolve to the infrastructure externally. It's often overlooked how split DNS can actually simplify all sorts of administration, and this tool makes it easy to offer split DNS to make sure those host names are gathered. Also, document your current DHCP ranges, as well as any changes that you might want to consider at the same time. Also document all your statically assigned devices, as they may also need to be manually changed. You also want to document your list of reverse DNS zones. This is an often overlooked area of good DNS management, so it's a great opportunity to do it right now. Document your current DNS servers that are offered internally. Some changes may need to take place to reflect your new desired outcome. Document your list of existing internal Active Directory servers if you have any. This is essential for rainbow lists, which actually contain your internal domains that need to be forwarded to Active Directory for DNS resolutions. More detail in the All About Rules lists and rule sets for further documentation. Also document existing proxy servers if you have any. The implications of removing your proxy in favor of this filtering and security stack has to be considered and planned for. For example, devices filtered via proxy may have never received a gateway before, but now they will need one. And devices previously filtered by proxy may have been provisioned manually or through group policy, which will require reconfiguration as well. Keep a list of your core business applications, which require internet or WAN connectivity. In whitelisting mode especially, it is essential that before any deployment, all required services are documented to facilitate a smooth adoption. And finally, verify that you have layer 2 visibility, i.e. the gateway is able to see the actual MAC addresses of every device. This software stack follows a device MAC address, which is an essential component to ensure policy enforcement is done on a per-device basis. While advanced users could advertise a non-native MAC address, the risk of this can easily be mitigated with a default policy of no internet access. And default policies and rule sets are applied to newly discovered devices. And you also want to document your current IPv4 and IPv6 configurations, as this is a great opportunity to simplify and streamline more of your networking. With all of this information and collaboration with a systems architect, the filter and security solution becomes a much simpler and straightforward exercise. From a procurement perspective, if it isn't already pre-installed, it's a matter of searching the marketplace for this software stack and installing it. Detailed instructions are available online as well. After the installation, it requires one more step to activate. An email is auto-generated to the account holder to access the cloud dashboard. Now, many administrators are concerned, for good reason, what interfaces, what ports are in use after software stacks are deployed. And so these are the ones you will spot with your favorite tools. First, in many cases, there's a TUNTAP adapter installed, which has a TCP listener on port 6373. And if you're wondering why 6373, well, it just spells nerd, no other reason. Secondly, the DNS resolver listens on localhost port 5553, which binds to both TCP and UDP for DNS purposes. But keep in mind, in most cases, this stack does not replace DNS mask, but rather becomes DNS mask's upstream path for all DNS resolutions. Third, localhost also listens on port 38473, which is the listener of the Don't Talk to Strangers engine, which is intimately tied to the resolver in order to know which firewall rules to create and destroy in real time. There are also IPv4 DNS hijacking rules in place, which serve the function of DNS policy enforcement, even if the endpoints attempt to use another public resolver. And on IPv6, the public resolver attempts are simply rejected. And the final firewall rule that is in place forwards block page requests to the listener at port 6373. This one is in place to keep complete compatibility with another Apache web server sites that may exist on the internal network. That's your introduction, your pre-installation survey, and procurement information, and we want to thank you for watching. Don't forget to check out the other content in this series.